Wetenskapens generaidkare och vänner med damer och herrar. Idag diskuterar diplomingenjör Ali Hanzala inom ämnet datateknik med sin avhandling Consistency of Human-Based Designs Using Ontology Prisoners. Professor Oscar Pastor från Tekniska universitet i Valencia, Spanien fungerar som opponent. Jag själv heter Ivan Porres och fungerar som kustos. Diskutationsspråk är engelska. On behalf of the Department of Information Technologies at Åbo Akademi, I declare that the public defense has commenced.
Honored custos, honored opponent, ladies and gentlemen. My name is Ali Hanzala Khan and the topic of my research is consistency of human-based designs using ontology reasoners. Software is a key element of our contemporary world. The presence of a variety of software is increasing in all domains of life. Nowadays, it's difficult to find a service which is not based on softwares. For example, we do shopping online using e-commerce websites. They all based on software. When we visit doctor, all our medical history is in their computers. They all based on software. And all the advanced machinery in the industry, they nowadays are based on computers, and they all are running on softwares. So software has to be developed, and its development is a complex process, and it involves both time and money. It starts with planning, then analysis and design, then implementation, and testing, deployment, and later evaluation. Software can have defects. A defect in a software can cause, and a defect of a software is kind of an error that cause that software to behave in inappropriate way and make the software to give the output which is not desirable. So nowadays it's hard to find a service which do not use software. Therefore, the failure of a software system may not only causes the loss of money and time, but it may also cause a loss of life. Boehm analysis says that the cost of repairing a defect increases exponentially in a software development process. If we fix the defect in the initial stage of a project, it will cost us as much less as compared to the cost of fixing the same defect at advanced stage of the development process. The lesson learned from the Boehm analysis is sooner to detect the defect is always cheaper to correct. What we can do about defects? One option is to ignore them. If we ignore the errors, we can get software ready very quickly, but that software may have a lot of defects. This is definitely not a good option for us. So another option is to detect and then correct the defect. This approach is used in software testing, where there is an iterative approach between tester and the developer, the iterations. And the same thing also happens in static analysis and validation approaches. Another method we have is to avoid introducing defect. This thing happens in formal method and by following the correct and construction method, by using logical proofs. So, as we learned from Boehm analysis that it is always economical to fix the defect as early in the software development process as possible. In this thesis, we focus on detecting the defects at analysis and design phase of a software development process. The software designs are often created by practitioners to analyze the system at design level. The proposed approach will help us to detect the defects in software design at very early stage of a software development process. It is an automatic approach and we do not need to put any extra effort in order to apply this approach into a project. Software designs contain a blueprint of a software system under construction. The analysis of design can be done manually, but in case of large system, the need of a mechanism that automatically analyzes these designs arises. In this thesis, we present an approach that automatically validates software designs using an ontology reasoner. What we are doing is we are translating UML designs into an ontology with the help of a translator which we have built, and then we pass the generated ontology to the reasoner. The reasoner infers the logical consequences in the logical facts present in the ontology. Then it produces the validation report. The validation report reveals the problems in a UML design. In this approach, we focus on the validation of designs that are based on UML, because UML is the de facto standard for modeling, and it is maintained by object management group. Another reason for supporting UML is that we can express both static and dynamic part of a software, both structural and behavioral content of a system. So we are also validating both kind of things. The reasoner we are using for the validation of UML diagram is Åbo reasoner. Reasoner is basically a tool that infers the logical consequences in the logical from a set of logical facts. We use ontology reasoner because it is fully automatic and there is a possibility to represent UML into Åbo. Åbo is a language for writing ontology, and we need to represent UML models as logical facts using the language understandable by the reasoner, so that we may be able to infer the logical consequences from these logical facts automatically using a reasoner. In this research, we use web ontology language, which is based on description logic and description, and Åbo DL is basically a decidable fragment of Åbo, and it provides context for the representation of many of the UML concepts such as classes, association, and links. The main contribution of this thesis is that we can translate and validate UML class diagrams, which represent the structural content of the software, and object diagram, which are basically the instances of the class diagram, the state chart diagrams, which are the behavioral, which represent the behavioral content of the system, and also the decidable fragment of OCL. OCL in general is not decidable, so but if we limit our approach to a limited fragment of OCL, limited and known fragment, then we can make that fragment decidable. Then we will be able to infer the logical consequence. We can do reasoning after that. And in the end, we are also doing the validation of the combination of all these diagrams. Our software project have many diagrams representing different viewpoint of a system. Or these diagrams can be structural diagram or can be behavioral diagram. But if we want to see a big picture of a system, we need to combine those diagrams, or we need to see all diagrams together in one frame. So maybe these diagrams at individual level they are valid, but when we combine them, it is not necessary that they remain valid with each other, or there can be contradiction of the concepts of different diagrams. So we are also validating the diagrams when they interact with each other, or when they combine. They can be a diagram of same meta model, or there can be diagrams of different meta models. In order to use the reasoner, Åbo reasoner, we need to translate the UML models into ontology, because the reasoner understands the ontology language and it doesn't understand the UML directly. So we have to make the translation tool in order to make our approach automatic. So we have built one translation tool that take UML models as an input, all kind of like UML class diagrams, state chart model, and class and object models. Also the OCL invariant it takes input in form of XML. Then it processes the XML that produces the Åbo ontology. This Åbo ontology we give to the reasoner process it and generate the validation report. Validation report reveals the problems in the input model. We have also validated this approach on more than 300 models available online in Atlantic Meta Model View. So these models, and we found that out of 303, there are around 49% of the models have problems or they are not well formed. And this also shows, and we successfully detect these errors, and this also shows the viability of our approach. And at the same time, we have also done the satisfiability checking, or the process stress test, we can say, the performance test of these reasoners. We are using Palette and Hermit, and we can see in the diagram that both reasoners are able to process these models in less than 10 seconds. So in this approach, we have presented a method by using which we can validate UML models using ontology reasoner. And this approach is limited in scope, but it is fully automatic thanks to the translation tool and the reasoners, automatic reasoners. The approach is decidable because it is restricted to a decidable fragment of OL2, that is O2DL, and the decidable fragment of OCL. And since the translation tool accepts the UML model in form of XML, it can be incorporated with the existing UML modeling tool which follow the standard which we are using. I call upon the opponent appointed by the department counsel to make any comments that he finds that my thesis gives rise to.
Thank you very much, and good morning, everybody. It is my role here to elucidate the nature of the subject dealt with in the thesis and its importance to research. So I would like to start with the first sentence that we saw in your presentation. So what is a key element of our model work, you were saying? Of course, I think that everybody accepts that this is a reality. And if software is a key element, to have solutions for producing software of quality is a very big problem. Software engineering discipline is looking for years a sound and reliable and efficient and effective software process in order to assure that a very simple objective is fulfilled, that is that of having software of the required quality. Meaning by required quality that the user requirements are satisfied. So it is a big problem for us as software engineers to see that after decades we still are looking for this silver bullet that could provide a software process as sound as other engineering software processes, production processes are. For instance, the automobile production lines are an example of a process line where at the end you have the product that you want to have, and you know that everything is going to behave in the right way. There is a long discussion in our community still nowadays about if we are software engineers or handcraft software handcraft workers. I think that it's hard to understand why producing software of quality is so complicated. But during the last 40 years, we are witnessing a lot of proposals that always are presented as the definitive solution to the software of quality production. We started with the assembler, that was the very first invention, but from that we saw the third generation programming languages, declarative languages, case tools, first with structure analysis and design, later with object-oriented modeling, aspects, components, agile methods, requirements engineering, business process modeling. I mean, it's just a long list of solutions that is probably very good for professors because we have always something new to teach to people. And when they know it, we just change the solution to another one. So it's clear to me that it's hard to answer the question of why is it so complicated. But it's clear that we need solutions. And model-driven engineering is trying to provide these solutions, changing the paradigm. There is a very interesting motto and a slogan that is trying to move the software engineering history from the statement that the code is the model, that is the code, the program is the essential artifact of any software production process, to the model of the model is the code. So other engineering use plans, use models as the natural way to define, to delimitate the problem, and to fix the kind of solution that is to be provided. We need models in the software engineering community. I am a follower of this movement. If we need models to make true this statement, the model is the code, we need to assure that the models have the required quality. And the topic that is faced in this thesis is just attacking this central point, quality of model. How to check the consistency of modeling artifacts. Using UML as reference modeling language, what sounds logical because it's a very widely accepted modeling language, and with a degree of automation as high as possible. It's a very ambitious goal that is really important from the research perspective. It is also relating different disciplines, model-driven engineering foundations, ontology engineering applications, because we needed to see that in practice these ideas are providing better solutions, validations, problems to be faced. But in any case, it's quite clear that better approaches are needed. And I think that that way is quite clear that the research that is presented in the thesis is important for the community. I don't know if it's going to be the last item of this list of solutions that they are trying to provide this final silver bullet. Hopefully, yes, who knows? But at least we need models. We need to assure that models have the required quality, and we needed to do that from an ontological perspective where concepts are properly defined, where tools are designed according to these concepts, and where applications are showing in some way that what we are talking about makes sense. So I just finishing with the same sentence. The first one, software is a key element of our model world. We need solutions to be sure that the software products have the quality that modern times require. And this research work is just pointing in this direction. With these words, I'm finishing my statement. And now I think that it's time to start the actual examination. Okay, let me put in order all my papers and all my notes. And let me start with a very simple statement that is the fundamental concept. We were talking about concepts, and I think that when we are talking about a problem that is being working around by so many people during the last year, to have precise concepts is very important. Ontologies are behind all the things that we were commenting, and many times in our domain, people are using concepts that we all assume that we share, but I'm not sure that is always the case. So you start in page 1, you say that the specification of a software is a description of a system to be developed. Okay, so my first question, I have very first question to try to show the importance of precising concepts. This is a fundamental issue. What is a specification for you? What is a model? The second definition, and what is a conceptual model? To be sure that we are talking about the same conceptual item. What is a specification? What is a model? What is a conceptual model?
The specification is basically a description what you need to develop. Like it's kind of a requirement, or that what things you want in a software, how software should be look like, what functionality should be there, what will be the structure of a software, what will be the behavior of software, and how each the structural things will interact with each other. So these kind of things are basically we can say specification is a software description written in form of text.
What do you think that it will happen if we ask everybody in the audience to write in a paper their definition of what a specification is?
Specification.
Would we have the same definition?
Not really. it's not necessary everybody has same definition, but the context will remain same. Like in the end, specification is the thing which we need that software should be look like. What kind of things should be there in the software. So the main context will be the same. Maybe the wording will be different, but context will be same.
What about the model? How would
Model
you define, let's define a model from your perspective.
Model
is
basically a visualization of specification.
Visualization of
specification. So if you are a software personnel, or if you are a software engineer, you know about software, you will create model by using some modeling ethics or some rules. By following some rules, you will create model. So that we can say that will be a software model. But if you are a layman, you don't know about software, and you are creating model, that will be a kind of a conceptual model. Because conceptual model is a thing which is based on universe of discourse. It doesn't have the formal thing behind the conceptual model. Whereas the model is basically a formal thing, or you can say the formal conceptual model, you can say is a model.
Has a model the same information than a specification?
Model can like I cannot say like it can express each and everything what we have in the specification, but we can at least express the structure of a system in form of model and also the behavior. But at some point we need to write some text in form of constraints or in form of operations that we cannot model in form of model.
What about the conceptual model?
In conceptual model,
what is the difference between model and conceptual model?
In conceptual models, there are no rules of drawing. It's open. It's all based on what you. If I'm drawing conceptual model for you, so it's only based on my understanding and your understanding. The rules are between us. But if we are drawing models, the rules are basically written in the books how to draw models. So we need to follow those rules. If we don't have any rule, we are drawing conceptual models because conceptual model based on our own rules. So this is the difference between.
Again, I guess that if we would discuss all this issue with colleagues that are working in conceptual model, it's quite curious to me to see that sometimes we get not exactly the same perspective. And why I am starting with these questions? Because to fix concepts in your work is very important because you are checking consistency of models.
Yeah.
So which models is a very basic question, and I think that there is something that is very important in this domain, that is what we call from the ontological perspective, ontological commitment.
Yeah.
I think that you are assuming that there is a common perception of what a model specification, conceptual model, ontology is, and it would be very good to have a kind of card where you present your ontological commitment. And you say, okay, to me, a specification is this, a model is this, a conceptual model is this, my ontological contextualization is this one. And when you do that, everybody is just, they can agree or disagree, but they know what you are talking about. Because in our community, I think that this is a problem. Many people are talking about models, and models is a so generic term that sometimes people are discussing, they are talking about apparently the same thing, but this is not the case at all. So I will go back to this idea of ontological commitment, but I think that this is a point that you should explore in the future. First, because you will fix your position clearly, no one could criticize you for not being clear. Second, because with your card of concept, you could discuss with others, you could exchange cards, and detect that for some people, a model or even a conceptual model is not exactly the same that you have in mind. And the ontology perspective is very important. There are a couple of questions on this direction, in the sense that the relationships between conceptual modeling and ontologies is very interesting for the information system community members. My last question in terms of this ontological commitment is, how do you relate conceptual model and ontology? Because there is, I have identified not only in your work, but in many well-known works, some contradictions or synonyms, commonalities. Is it the same? If it is not the same, what is the difference between an ontology and a conceptual model? When you are talking about an ontology, you could just make a kind of cut and paste and use the word ontology there or not?
To me, like if we draw conceptual model, we will have the graphical form of conceptual model. But if we want computer to understand the conceptual model, we need to write in form of a language so that computer may understand it, because computer don't query the graphics. So we need to write those conceptual models, the graphical conceptual model, in a way, in a language that computer can understand. So the ideal language, people say, like the conceptual modeling practitioner use that language is basically ontology web language, and they represent in form of ontology. So to me, like in order to computer to make conceptual model understand, to query them, because if we have some conceptual models, if we have conceptual models of some, let's say, some scenario, XYZ scenario, and we want to query them, so we need to write those conceptual model in a way that we can query them. So as we have Sparkle query, we use with ontology reasoners. So if we have a conceptual model in form of ontology, we can use Sparkle querying, and we can query in the same way as we do query database.
Mm-hmm. Okay, so
even it is also not only the conceptual model are not only working as a model, they are also in some way working as a schema of holding information of different knowledge base. Because in knowledge engineering also, they are representing knowledge in form of semantic web things, and they are also representing knowledge in form of ontology. So it's now about knowledge, and the knowledge engineer, it's all up to him how we extract knowledge from the people and how he represent that knowledge into a model, and he model in that way that it can be understandable by computer, so that he may store the knowledge in the computer. Because the main problem nowadays is to acquire knowledge from the people. Because if you are a key personnel of some company and you just left the job, so all knowledge you have in the brain you are taking with yourself. So there are knowledge engineers who are basically responsible for extracting the tacit knowledge of the main employees and put it in form of some model or something into a computer, so that whenever new employee comes, we just see that knowledge and start from the same level where the previous employees were working.
Okay, so now maybe my point is clear for you now. That is the following one. I think that you know that there are two different uses of the term ontology. We have the model, the UML model. I don't know if this could have been explained in your word. UML model or UML conceptual model. This is the difference between model and conceptual model. And there are two different acceptions of the use of ontology. There is a low-level ontology, that is the one that you are working quite strongly. It's okay, we are going to translate, to convert, to transform the UML model into a low-level ontology to clarify semantically the things that are present in the model. While there are other people from a more philosophical perspective talking about fundamental ontologies, the high-level ontologies. These ontologies are just fixing what kind of conceptual primitives this conceptual model should have. So I think that you could have, and this is still very valid for the future, you could have a kind of picture where you put into a graphic these two different things, high-level ontologies, to determine what kind of model you are interested in, consistency checking, and the transformation, the low-level ontology that is going to be used to check this consistency. So there are two things here. How high-level ontology versus low-level ontology. You are making a strong work on the low-level ontology, but you are ignoring the high-level ontologies. And the second problem, that is if the model or conceptual model is just the same or the different term. Do you agree with this perspective? And do you think that this, why not including in your work this high-level ontology, either in the introduction to fix or to contextualize the work?
Because my work is based on UML, and we are basically using ontology just to validate UML. We are not. There are two things. One is that I am not doing is ontology modeling using UML. And then the thing I am doing is UML modeling using ontology. So there are two. And the thing about the higher level ontology and lower level ontology, I agree with you, and I have worked on this before my PhD. So the lower level ontology, they call it domain ontology, and they was made by the technical people. And the upper level ontology, they was made by the management stuff, like the people who are not, they are technical, but they are not that technical that they are working and building the things. So they just place the big blocks, and the developer kind of people, they are making the domain ontologies so that the main picture can work. It kind of like you want to build home, and you hire an architect. You just tell him, I need 3 bed and 2 or 1 drawing room, and the structure should be something like this. So you can draw some sketch and give it to him. The detail architect will put because it's his area. So the upper level ontology will be your thoughts, what you want, and the detail, that what will be the diameter of the room, and what kind of furniture, what kind of pipes will be there. The minor detail will be put by the professional. Even in more detail, how much the concrete and sand will be involved, it will put by the main civil engineer. Then it will go to step by step, the detail will end.
This conceptual clarification is very important for the community. There is under the information system community, the conceptual modeling community, there is a workshop on conceptual modeling and ontologies that where you could contribute a lot in the discussion. So I think that is a reference to be considered for the very next future. Because this, when some people, when you have both perspectives in mind, you know what you are talking about. When you have only one, as I said before, this ontological commitment is not present. And some people are going, for instance, people that are working with high-level ontologies are going to look at your PhD title, and they will think wrongly that you want to do something that is impossible, that is to check consistency of concepts of high-level, real-world concepts. That is not what you are doing, because you are using the other concept of the low-level ontology, as you said. Okay, in this line of argumentation, I saw that there is a very interesting reference that is at the book of conceptual modeling of Antonio Olive. That is, he's just talking about conceptual modeling, not about ontologies and low-level ontologies, but I think that is a reference that you have to take into account, because he's just putting all these ideas under the same framework. And for extending what you are doing to the high-level ontology community, you need that. So I will also give you this reference, because I think that is a reference that should make part of your work. Okay, so let me move now with another comment that is, when I saw what you did, I like the structure, the practical structure of you present the approach, and you make applications that are all of them interesting. But it seems to me that you were discovering new application domains as you were applying the idea in practice, and you were getting new ideas. And my question, you could have had, instead of 9-10 chapters, if you have 5 more years, you could still create more consistency check. The question is, instead of this kind of ad hoc list of application domains, have you thought in trying to categorize what kind of model consistency checks the model-driven community needs, at what kind of transformations are more feasible than others, to try to create a kind of taxonomy of useful, needed, and not useful or not needed transformations. To try to categorize, you could propose, for instance, if I could ask you, what is next? What kind of new consistency checks you want to perform? You will have to think, and new ideas will come. But there is any way any attempt to conceptualize this and to see what kind, could I from the meta models, could I abstract in some way, could I create a taxonomy of useful transformations for consistency check purposes?
Up till now, we are more focused on the UML based designs, and we are still limited in scope, even in UML based designs. So with the passage of time, yes, we can do. This can be one option for the future work. And that building a taxonomy is kind of a very big challenge, and we can do this as a whole research project. This work. Because in order to know more problems, we need to explore more applications. Because application tells us what is the lacking in your system. So the lacking will be the future work. Oh, this is the lacking, we are not covering this part. So application will tell us. So we need to explore more applications so that these applications may test our system, and they when test our system, these applications will explore the holes in our system. Then we may know oh, these are the lackings. So we will fill those lackings, and while doing this, we can make one taxonomy like we have done this, we have done this. So slowly, if one person is working in a project, then it may take years. But if there is a big group, and if it is whole and soul, if this is a project to make a taxonomy, and there are a lot of people, then we can do this.
It would be interesting to explore here the potential connection between this high level and low level ontology issue. Because as you are working with low level, you see applications that jump into the low level ontology in a natural way. But if you think in terms of the meta problem, the meta models, maybe you could identify a relationship of the meta model, and these meta ontological relationships, meta model ontological based relationship could indicate that there are transformations that make sense. And when you don't have such kind of meta relationships, meta conceptual relationship, it means that it makes no sense to invent or to propose any transformation. So again, we go to this ontological commitment issue of clarifying things in order to create the right connection.
Yeah. I had also one experience with this ontology stuff. Like we have two different ontologies, and they don't have any transformation relationship among them. So what we did, we put header on both of them. We make one kind of meta model, which is combining the key elements of both ontologies and joining them. So if we don't have a translation directly or transition, we can build one in form of header. If you want to combine them together through meta model or through header on both models.
Okay, thank you. So I move to the background now. And the background, I think that your work is just facing a key problem of the model-driven engineering community. This is a good thing. And this good thing is not so good when you refer to model-driven engineering, because I think that your references are too close, are too restricted. Mainly because I guess you said before that you are focusing on UML. So you have restricted your model-driven engineering view to UML, while there is more life in UML, and your ideas could be applied also to other modeling notation. So you were referring to model-driven engineering only. We were two references to the OMG, and the 55 is the Kent, the model-driven engineering book. I think that you should increase your perspective, because you could have your work could influence people that are, for instance, working with tools that are not exactly for any reason. Imagine that people are making transformation from BPMN to some kind of behavioral diagram that is not UML. So you could use a meta model for BPMN or any other modeling technique, and your ideas in terms of checking consistency could be applied in the same way. So my concern here is that you should do that. I mean, you can have an influential work for the model engineering community. You should work with the models community, the ER community, the KAISE community. You will see the models is probably the UML one, so you are going to feel very comfortable there. But your work would be very, very highly appreciated in KAISE, in ER, and I think that in these forums is going to be also extended because you need to have a broader perspective. Do you agree with this? Let me now go to the problem that is behind all the proposal, that is the UML semantics. Now we just enter into the UML, that is the domain that you have selected. When we talk about UML semantics, you know that there are many critics about the lack of preciseness of the semantics that the UML meta model provides. So if the UML semantics are somewhat imprecise, or there are discussions about it, what type of constraints is this problem imposing to your work? Because if the meta model, the UML meta model has some vagueness, conceptual vagueness, if you want to check consistency, you are going to charge on your back some kind of fuzzy semantics that will affect the result of the consistency checks that you want to do. Have you thought about this problem, or how to minimize it in some way, or to face it in some way?
In this thesis, we are also validating UML models, UML meta models, and the meta models which are based on MOF and following the norms or well-formedness of MOF. So we are validating the meta models, also validating the meta models.
But for instance, sometimes the UML meta model semantics are open to interpretation because it's not precisely what to do. So the scope of the transformation that you perform is also limited in some way from scratch by definition. I have an example of that, is the inheritance. You have in UML inheritance and you have specialization, okay, and you assume that you can, for instance, specialize the operation of the parent in the child class. But what about modifying the behavior of the operation? Can you modify the operation in the child, making it contrary to what was done in the father, or not? This is not said in UML. So this is open to interpretation. If you want to check this consistency, there is no way, because it's not there. I am referring to this kind of things. Are you aware of the limitations that this lack of a precise formal basis in UML semantics is providing to what process?
Yeah, there are a lot of limitations, and that's why people are also using OCL in order to overcome structural kind of limitations. That things which we cannot represent in form of UML, they are representing using OCL. So if the problem you have described can be solved by OCL, then we can look into it.
I have a couple of questions also related to OCL, so we will continue with that later. Following with this issue of the UML semantics, I would like to ask you how to select the right UML diagrams and the right combinations. I mean, when you do something, for instance, an instantiation of a correct consistency check, that is okay. I have class diagrams for structure, and I have state charts, state diagrams for behavior. And you demonstrate that under this assumption, you make a consistency check that is useful. But again, the question is how to select. You did one selection there. How to select the right? You know that UML is plenty of diagrams. So how to select the right combination of diagram to provide a transformation that makes sense? Just based on practice, or because you have, as I said, you have proposed a couple of concrete instantiations. But because you were one day you woke up artist and say, oh, I would connect class diagrams with state diagrams. But if you want to do that from a software process perspective, and you want to join different pieces of a software process within the UML diagrams, and you want to check the consistency of that. How you thought about it?
Actually, behavioral diagram which I have addressed in my thesis, they are basically representing the behavior of object of a class in a class diagram. Like in class diagram we have many classes, so it can represent a behavior of an object of any class. So it is basically, we can say, state diagram is also kind of an object diagram which is representing a behavior of a class, and how we are joining both of them is actually by using OSTEM, the state invariants. So if you can join them by writing invariants, so we have something which we can, like, if you can draw it, we can also map it in form of ontology, and then later on we can also check the consistency. But this scope is limited, and there are some limitations also. Limited in scope have two meanings. One is like we have done things till some limit, and there are things which we cannot do, which is not possible within ontology. So there are things. But if we are only about checking, we are only thinking about taking the right combination, and only we need to draw things. We are not thinking about checking consistency, only how to choose the right combination. These things depend on the experience.
I think that this is related to our first comments of the high-level ontology.
Yes.
Because I had a question for you about if is there any fundamental ontological commitment to fix the required conceptual primitives that conforms a correct conceptual model. And if you have an answer to this question, you did a high-level ontology where you are, for instance, deciding that you use a subset of the class diagrams for a specified structure. For every class you use a state diagram to specify behavior. You add with OCL some expressions, some post-conditions to specify the functionality. You maybe use cases to specify or to complete the requirements perspective. And if you detect all these required conceptual primitives in an initial ontological commitment at the meta model level, you can define the transformation, or you can characterize the transformations that you want to do. And the thing is that if we want to do that, if we don't do that, how could we assess the completeness and the correctness of the models that we are using for checking consistency? And I think that this is an open problem of the current study approach, because you provide a solution, but I believe that there is no way to make any proof about correctness or completeness, because we cannot compare against anything about any high-level ontology. Is that right? So I think that again, if you join this perspective, you put at the input instead of just a flat conceptual model. You define some open ontology, high-level ontology definition where you identify what is going to be checked. You have an open starting point that would provide a dynamic, in some way, an adaptable set of transformations depending on what kind of elements you are connecting. I had also again here this question about what about semantics, that when you are relating UML elements and all elements, there is a concrete transformation there, but I guess that there are elements that have no direct mapping. So
almost all elements expressed here, they don't have direct mapping. Because there is a fundamental difference between ontology and UML. It's an assumption. Ontology is open world and UML is closed world. So the things which is written here, it is logically close enough or logically equivalent to the old two exams logical description is equivalent to UML concepts logically in this. But on above all these things, there is a fundamental concept of open world and closed world presumption. So other than this, we have added exams to make to create a closed world inside the open world, because we have to define the world of UML
Talking about completeness of the transformation, have you found anything that you could express in transformation that didn't have any kind of counterpart in all? Some
Yes.
kind of missing the specifics?
Yes, there is a list, just on the same, this one.
Mhm.
So in this list, all these elements don't have equivalent O2.
And how do you solve this?
Yeah. What we did by using the existing one, we have made a combination of existing O2 exams and make a equivalent, logically equivalent exams of the ontology, equivalent to the logical, equivalent to UML. Like we have used description logic for this. We have written the meaning of some concepts which are not present in O2. We have written the meaning of those UML concepts in form of description logic first. Then we write the meaning of the ontological concepts in form of description logic. Then we merge them. Then by combining 2-3 exams, we come up with a equivalent of that UML DL thing, so that it becomes logically equivalent, logically mapped.
The question
of
about
all these things.
the question about completeness were more related to the fact that if this list was complete for you, you didn't miss. There was no conceptual primitive that you were not able to deal with in some way.
These are the things which we have successfly.
Yeah, there are. Have you a list of the others that are in the bottom of the?
Because the one thing about, like, in my opinion about me is, like, I cannot give surety like this thing is impossible. So I always, in my mind, I think it is possible, but like. I have some limitations, but it is possible, because everything is, according to me, everything is possible to some extent.
But if you provide a correct partial solution, you are going to get always the question of until which point this is a partial solution, and how could I buy the complete solution? So in some way, you needed to fill up this gap, saying, okay, I'm giving you 70% of UML, but this 30% lacking is not so important. Or yes, I think you must fix that maybe experimental.
Yeah.
I have a couple of comments about it also. We can go back to that later. Just a small comment in page 22. I think that in the figure 2.6. I was just had the curiosity of you have to an object diagram in the model level M1, and also an object diagram in the instance. Is this a mistake, or this is just a different use of the diagram?
It is they both are same thing actually. They both are same thing, and because we also have instances. We have instances at M0. But if you want to draw the behavior, because as I said, state diagram is also an object diagram, because it is telling you the behavior of objects. So behavioral diagrams are also object diagrams. So behavioral diagram, the structure diagram is also in category M1. It is also object diagram. Similarly, object diagram is also object diagram. But at M0, it is basically we are talking about real instances. The instance, the object which is going from state to state, traveling whole behavioral diagram step by step. At M0, we are talking about that specific instance. But when we want to draw something, we draw in form of state chart diagram, we put it at M1.
Okay, so let me now go to a question that I find very interesting, because it's a matter of methodological question. I mean, you are in the basis of your proposal is the fact of automatically translating UML and meta models or UML models into all true and analyze the translation using the reasons. Okay. But I mean, if you have UML and you convert in all, and you know that many people, because of this misuse or this not clear comparison between ontologies and conceptual models, some people in the modeling community, the web semantic community, are using all for modeling. So why not modeling directly with all and avoiding the UML? What means that your work wouldn't be necessary? I mean, this is a question that you should answer clearly, because one could say, okay, if I have to transform that and I am an expert in all, let's do it directly in all. So what would you say to these people?
First thing is they are doing ontology modeling, and in reality ontology don't have formal notation. So they are using UML or some other notation in order to represent ontology. There is no formal graphical notation for ontology. And first thing is this. Secondly is that they are doing ontology modeling. So if they are doing ontology modeling, they don't need UML constraints. They can use UML notation, but they don't need to follow the constraints. So they are basically using UML in their open book. So that will be different thing than this.
Some way you could be propose something inverse. I mean, going from all to UML also, because the people that in the web semantic community are doing all modeling, of course they have, as you are saying, they have limitations, and they need UML constructs. So maybe they should add a kind of UML layer to convert their, or just to work with all as if they were being working in UML. Do you think that this would make sense? Or?
Yeah, because
I think it's strange. I think that maybe the people that invented all should have been extending UML with resonance instead of creating a different language.
Yeah. In order for the reasoner to understand the things, understand something, the things should be decidable. Decidable means the things should be there formally and they are complete. Like decidable means, like if we have OCL, they are still, I think on daily basis they are creating more and more constructs. They are still making OCL now. So it is not decided. Similarly, the notation for ontology, because it is not up and down decided, they have not decided what is the formal notation of ontology. It is also not decidable. So in order to process the ontology, we have to somehow limit ourselves so that we may query the ontology, we may process the ontology, and a reason will know, like, this is the word of ontology, or at least this is the syntax which I will understand. So if we talk about the exams or the construct, the language of ontology web language, this is decidable because we have OL2DL which is decided, we can use that one. But when we are drawing this, we don't have formal notation. So it means things are not decided yet. So it is undecidable and we cannot process it until they are decidable. So what they are doing, they are using UML, because UML at some point it is also a decidable thing. Because it is well written, and although there is not much formalization exists for this, but still it is there is a lot of.
I know what you mean, but I'm still wondering if people that are using all could just introduce or extend all with some kind of graphical diagrammation and in the UML style, and could just adapt the way in which they use all to the UML, and at the end the result would be quite similar. And I also believe that maybe the issue is that the people from these two communities are working in parallel, and sometimes they are doing almost similar things, but without knowing to each other. They are exploring, running in parallel, and sometimes now they see that there's a connection that could be probably faced directly, either linking UML specifications with reasoners, or extending all with some graphical capabilities. Maybe you are in a good position to define this gap, as you are doing with the transformation that you are proposing. You could answer the question is, well, just related to the next question, because your work assumes that a correct transformation of a UML class diagram into an old D2 ontology is always feasible. How to prove that it's always feasible? Because what is clear is that it's feasible, it's possible in the cases you have experimented.
Yes.
But could you generalize this statement to any
No.
UML diagram?
No.
And how to know when this is possible and when it's not possible, when it makes sense, when it doesn't make sense?
At some point, we have to introduce human being for some things. So the things which we have done in the thesis, and if you are using the basic concepts of UML diagrams, then you can use this approach. But if you want to test this approach and you want to take the process of validation and if you want to take examination of this approach, so you can give this approach tough time and you can make the diagram like this, like it cannot be processed. But it all based on experiments. We need to do experiment and then check. Like up till now we did experiments actually. We have used around more than 300 meta models available online. They all are based on different languages which are which really exist. That's the real thing. And we have tested the real meta models, and out of those 300 meta models, 49% of meta models have errors. Our approach found, and I think this is a contribution because we have able to find the around 50% of the models have errors, and our approach have able to find it. We are not claiming after using this approach your model will be error free or we can find all of them, but at least we can find many.
Following up your comments now on the validation of the Atlantic Zoom, when you detected all these failures, all these defaults, have you got any precise lessons learned to understand and to make to create some body of knowledge that could be useful for people that are modeling? Were you able to create this list of conclusions, saying, okay, these were the type of modeling faults that were committed, and so be conscious of that in order to not repeating this problem? Did you do this?
Most of the errors were found are very basic errors, if they have made if they analyze it by themselves, they can also we can say these errors are mistake actually. Most of the errors are mistake by the people who are making the models. So there is a multiplicity problem, there is maybe a cyclic problem of composition. So a lot of things are due to the mistake.
I miss this very convincing proof of value in your work. I mean, you have made a proposal, you have made experiments to show that it makes sense, but I don't know, maybe it's to say too much, but it would be very good to say, okay, you know that the model driven in any industry is using tools and they don't prove, it's hard to measure the quality of the models. What I'm missing is some kind of concrete evidences where you have applied the problem in an industrial setting, and you have proved that doing things or using your approach, the products of the company will work better, or the institution will work better. This kind of evidence, do you have any kind of concrete evidences that will show users of your approach that the life will run better if they use the tool, compared with not using the tool?
Yes, we have in the appendix, we have the list of errors of all the meta models that we have found, and we have made the categories like in appendix A1. We have composition cycle error. They're all based on composition cycle error. Like there is a there cannot be ownership cycle. Like
No,
if you are my owner, I cannot be your owner.
But I mean a kind of document of the company that are using this model saying, okay, I did that,
Yeah.
and it was right. I mean, I know that this is your opinion, and
Yeah.
it's well justified.
Yeah.
But do you have any empirical evidence of a concrete improvement for a company or for in a practical setting?
Yeah, if like we report these errors
Yeah.
to the owners of this meta model, that will be a concrete contribution to the
And they learn from this, and
Yes.
they are now doing things
Yes,
better.
but what in reality all these models are reported to Atlantic Zoo by the researchers, and they got these meta models from the companies, and companies are very reluctant to give their original meta models. So in my opinion, what they did, they have given either the old versions of their meta models, or they gave a part of their meta models for researchers for research.
It is maybe further
Yeah.
probably, but what I'm meaning is that you know that there are conceptual model compilers and there are companies
Yeah.
doing model-driven model transformations
Yeah.
for model-driven development tools, and they have a problem that is called in the field of model-based testing. They should test not software but models.
Yeah.
And it's hard to see there are many industrial tools, model-driven oriented, that are in the market now, but it's hard to see any kind of serious, rigorous, efficient, for instance, consistency check analysis of models. So I think that your approach should be, you should join, meet this tool builder, and they should be interested in that, because I guess that if they can check this kind of properties when in the model building process, they are going to get benefits, because their models will be better, so the transformation will be better, and this is the evidence. I think that your work should provide more than the scientific evidences, that is the main goal that is done. Also, this empirical evidence is because it's the way in which you can make people use better model-driven development. And my question initially was just trying if you have had any kind of industry connection, but it is too early probably, according to what you say.
No, up till now we don't have, but our product is open source, and it is available on internet, and the detail is in my thesis and also in my papers. So if you
some
anyone
believer that is just going there and providing you with the evidence. Let me just make a question related to related work, because I was evaluating some work related with Tao's approach, and it was the first time I wanted to see if it was in the what it was there, and I think that is well referenced. But I mean, as they use DSLs, normally I think that they could say a user of Taos or a builder of Taos, if he's comparing their work with yours, could tell you, okay, if I create a DSL representing state charts, for instance, diagrams with state transitions, I could have the same. But is that true or not? I mean, just creating DSLs, they could do something similar, or it would be something still missing?
I have used and in order to use this, we need to draw everything in it. We cannot open any other XML file or any other document which we have created in, let's say, Magic Draw. We cannot open it. We have to use this tool. The main drawback is this, and main the edge of our approach is that our approach can understand the models which is created by any standard model.
So it's a matter of openness.
Openness.
Okay, I mean, I think that they would say that, but it's not a good solution, because they should create a DSL for any case what is probably too costly. Okay, so now I have something more related with with the OCL that I promised you before, that I think that you have already commented. This is an important point of the thesis. You see some places that you talk about the undecidability of UML that can be avoided if you limit your approach to non-construct of OCL. I mean, limiting the use of OCL, just using a subset of OCL, you solve this problem of undecidability. That's a good point. You make it decidable.
Yeah.
But how to assess that doing that you are not losing relevant information, or you are not losing an expressive power that probably you need when you want to solve a real problem. Have you evaluated, it's clear what you are winning, because you need to have something decidable, at least you, I mean, maybe it's not a Formula One car, but it works.
Yeah.
But it can still be a Formula One, or is a limitation that is going to be hard for the evolution of the idea. You know what you are missing in doing this reduction of OCL?
We have limited, we have chosen very limited set of OCL constructs. It can be expanded, but we have choose the basics one, like the value operator and the Boolean operator and the cardinality operator. The basic ones which we have see in most of the OCL constructs. Because OCL in general, if we see the OCL constraint, they are using their own, because a lot of people have their own maybe compiler of OCL, so they are not they have introduced lot of constraints which may be, you can say, domain specific OCL. So we cannot go into domain specific OCL thing. So in general, the common construct which we have found, we have implemented, and it works successfully, and in future we can expand it more. Yes.
I think that this is clear, and this is a step beyond. I mean, you make a reduction, and you demonstrate that it's working in some concrete cases, but this is still an open, important point related to what kind of missing information can I be missing out. And I think that this is an open question that needs exploration. Because as OCL is a language, depending on what kind of formulas, imagine that in English now we limit the syntax, and we are using some very simple sentences that for a given context, okay? But how to define clearly what can I say with this subset of views? What cannot I say? What I'm missing? Maybe in practice this will come when we want, or you need a user need to express something. And so if you add it, you extend it, you have still the problem of decidability. Maybe the extension is possible or not. So this is a huge problem that's in some way simplified in this version, and needs further exploration. Do you agree?
Yeah.
Let me go back to this with the application. Some of them are really, I mean, it's a good thing that step by step the complexity of it seems that you were discovering that more and more things were possible. So the consistency of multiple UML diagrams is a very interesting one. We have already commented something about this, but going back to the high level ontology issue, many consistency analysis could probably be avoided if a tool is implementing according to the rule that the meta model is precising. So in that case, if it's right, it seems that we have two kinds of consistency checking. One is consistency as a logical consequence of the tool, would be given by the tool implementation, instead of consistency as the result of a transformation and validation process that is what we do in the PhD. I would like to know your comments about that, because we are kind of competence to your work. People say, no, you don't need to transform and validate. You need just to go to the meta model and build a tool that is just mandatorily, obligatorily, you have the right things, because the tool is just letting you to do what is correct. It would be another way of applying your ideas. What do you think about this?
If we build a tool, let's say we have a meta model M, we will build we will hire someone developer. We will build tool EM. So we have some. Then we will able to validate the model. Then we create model, and we will validate it against it after going through this process. So if you use our approach, you can have meta model M1, M2, M3 to Mn. This is the meta model layer. You have model of this meta model, model of this meta model, model of this meta model, and model of this meta model in our approach. And we can check we can validate n number of models against n number of meta models. And what effort we did is basically we have implemented this thing only once. The effort which we do for every meta model n times, we have only did this thing one time.
Okay.
This is the.
You mean that you will need one tool for each
One
model?
tool, yes.
The other, no?
Yes. On the other hand, you need to do n times. So we are using the effort n times.
Okay, so I also had some comments related to the model-based testing that I said before. I think that is a very interesting space. It was interesting to me why it's not precisely introduced in the work, because you have it. I mean, you could present your work in a model-based testing context, saying, "Oh, I am providing a UML-based consistency checking approach that could be used to test models and to be sure that they follow some kind of good properties." Why you haven't used this domain, this domain of model-based testing that is very important in model, very new, and it's just is something that is looking for works that are looking for solutions that could be applied in this context.
I have not explored much this model-based testing, but as far as my knowledge is, according to my knowledge, we do testing by using models in model-based testing. So in the end, we need valid models in order to do testing.
Yeah.
So this is all this also this work can also work as a foundation of this.
It's a good point. You go one step beyond.
Yeah.
Instead of doing conventional, even if
Yeah.
a new discipline, instead of doing conventional model-based
Yeah.
testing,
Yeah.
testing with models,
Yeah.
you just use ontologies
Yeah.
for testing.
Yeah.
We don't have to create additional models.
Yeah.
You just go to the model as an artifact
Yeah.
and you test it directly. So it's an interesting point. Maybe you can explore that, because it is an interesting result for this community.
Once I was discussing this thing with one of my colleagues, so he said, like, if we make some ontology compiler, then even we don't need to write a code. We just create model, and that language you are, like, the models you are drawing is basically your software. Like, in the code behind of that model is basically ontology, and if you create ontology compiler,
Yeah.
then basically when you draw things, you are creating your software in the background. So you create another programming language, which is a graphical programming language.
In some way, you are working on this idea that I was commenting at the beginning of making through the statement of that the model, the model is the code.
Yeah.
Because the model, the conceptual model becomes the key software artifact.
Yeah.
There is also another application that I want to comment with you, that is, there is a new term that is now fashionable in some software engineering context, that is the capability. Capability required for service design, for example, capabilities as a service. And it's an interesting word, this capability word, because it exists in English, in German also. I don't know if in Finnish it exists, but in Spanish it doesn't exist. We have capacity and ability, but we don't have this word of capability. So capability is consistency in a service. Could be. I mean, you could provide that is an open source. Would it make sense to provide or to sell your approach as a kind of consistency, model consistency as a service that any model builder could use? Does it make sense?
Yes.
And okay, meaning in that case you should also explore this capability notion because it's an interesting space of work there, especially if you are working in the open source community. Okay, I have also here now. I wanted to comment. I like the example of irreflexiveness when you have the self-excuse. That is quite clear. But it's a good example to discuss genericity of what you do, because I was wondering how do you solve this. I saw the example. In this example is clear, but again, my concerns sometimes reading the analyzing the PhD is how to generalize the result. When you do it for this concrete syntax, but I would like to discuss with you the genericity of the transformations rules between OCL constraints and all representation, because it's a language-to-language representation, so as in OCL, even if you reduce it, you can find any kind of well-formed formula. This example is just a simple example. I mean, how do you solve this? Just putting together all the examples, or you have a kind of transformation grammar, or how have you done it?
We have transformation grammar, and what we have is, and grammar is also there, what we are using in OCL, but these rules are basically, we have the translation of the OCL construct which we are using.
Yes, the subset that you were talking about before.
We have written the translation rules, and then we have implemented those rules in our translation tool. And whenever there is a reflexive stuff comes, it will translate it in the same way.
I think that this, I mean, should be, I go back and I close what I said, I told you before about the price paid by reducing OCL. I think that this is, if you look at this grammar, you could argue on what kind of reduction you are making in practical terms. Because for instance, I'm sure that when you face this kind of OCL expression, this is going to work perfectly. But I wonder in terms of genericity, I don't see it clear. So I think that this is something that needs probably further experimentation to provide a very reliable solution. I wonder if you apply this in different cases, you will find always the required specifics to succeed in the representation of the problem. Just a short question beyond the edge in some way. I think that this is far from the objectives of the PhD, but the MOF level is always the M0, M1, M2 is clear, but M3 is always a kind of mystery, and nobody say anything about that. I would like to know your opinion about what type of checks could be done in the context of the M3 level. Because if you check consistency, what does it mean? What would it mean to check consistency of the meta level? Would it make sense? Because your approach could work in the same way. So you could introduce new human conceptualization elements, and you could check that the UML, for instance, is right or not. I don't know. I would like to see if you have an opinion and position in this context.
According to me, like in my opinion, this M3 is basically we can say a Bible of UML. This M3. It has written, it has like things which is defined, and like what is UML is basically M3.
But in some way this means human conceptualization, because UML wants to say, okay, everything for a human brain should be modeled in terms of classes with attributes and classifiers and so on. But everybody accepts that, and it is not a check in any way. I mean, what do you mean by, do you believe that another modeling technique could have a different...
Yeah, because in world there are a lot of beliefs, And people who don't believe on UML, they can use KM3. So there are other things also available. But if you are fan of the UML, then UML is M3. You have to follow this. If you are a fan, if you want to use UML, you need to use M3. It is UML, MOF. And it has everything of UML superstructure specification there. Lot of well-formedness rules there. Everything is there in M3. So what is UML is basically written in M3, and if we make some model using UML, it must follow the guidelines how to make the model, because it is the language which is how to create model, how to put association, how to put classes, how to make combination, each and everything written in MOF. So if you have made model, it must follow those things. So this thing we are checking, either it is according to the language or not.
So in principle, there is no limitation to apply your consistency check to this level also. We don't know for what purpose.
If you are comparing MOF with MetaMOF, but there is no MetaMOF.
There is no MetaMOF.
Yeah. So at one point we need to stop. Like there is no one. This is the maximum
Yeah,
level.
of course.
So if
But I haven't seen an experiment comparing the M2 against the M3.
here we have M2 versus M3. Yeah.
The meta model.
Yeah,
right?
meta model.
But with a different M3. I mean, as modifying M3, adding some new expressiveness, and some new construct.
That will become domain specific M3. But that will be very big domain.
Okay, it's a little bit beyond the edge, as I told you, but this is an interesting point. Some very much word-oriented, low-level problem. Hermit versus pellet. You have become an expert in that.
Yeah.
You made some. I mean, you say that the efficiency of the two reasoner is satisfactory for the. It seems that I guess that you prefer pellet, but I'm not sure. Well, after all your work, if you had to evaluate, to compare them, what main headlines would you say?
Up till meta model validation, we have used both pellet and Hermit in order to confirm, in order to make confirmation of our work, like it is okay. Like, so our work, our translation is run by two different reasoners. One reasoner pellet understand the old function syntax, Hermit understand old to Manchester syntax. So we have produced both of them, but in thesis we have only shown the old function syntax, which is understandable by pellet. So they were producing almost same results, like we can say 90% of the time they are producing same results. But pellet was the reporting of error, the capability of error reporting was of pellet is better than Hermit, but the processing time of Hermit is better than pellet. So in terms of processing, Hermit was better, but in terms of error reporting, pellet was better. So that's why in later parts of my thesis I removed the pellet.
Okay, let me just move into the end. I was also interested in the application on the REST web services because it's a web engineering issue. I think that you were relating in this case not only model-driven with ontology engineering but also with web engineering. Yeah. It's interesting the proposal and the results. The experiment, there is a lot of experimental space there. I was missing this experimental perspective because you know that the web service industry is very strong. It's a similar kind of question, but related with web services in particular. Any concrete contribution from this practical perspective? I mean, how would you sell your idea to web services designers and developers that are developing strong web services, and you should convince them that their designs would be better using this? I guess that there is no experimental evidence yet. Is it right? If yes, you just explain me them.
Yes.
And if not, tell me how would you reach this audience?
To me, this is only one application, And what we are proposing here, we are proposing the validation of UML models. It doesn't matter in which product you are using your model. If you are using a UML model for some other project, so we can validate that also. It is just an example. Like in web service, the web service interface, you can represent the web service interface using UML models. And our work starts from UML models. Like we don't have any concern like what they are doing with it. We know our work starts from UML model. Whatever it is in UML model, it doesn't matter to us because we are validating UML models. So beyond UML model, it's our work. And from where it has come, it's not our work.
You mean the customers of your approach should be people that are building web services using UML?
Yeah, because we are validating UML models. So main focus is UML. If anyone who is using UML, our approach is useful for them.
In any case, I mean, as I have already commented you before, there is a lot of experimental space in this world.
Yes.
We need experiments. I think that you are opening a lot of windows or doors, and we need to open the door and go beyond and prove. Because proving, experimenting, probably new improvements will come to the world. When you talk about the other application, consistency of class and object diagrams, I was also curious about the fact about how you think that these object diagrams are generated, because it was a kind of a priori consistency check. That means, okay, is the same that we were talking about when you were drawing this example before, for the object instance perspective. If you have all the checking in the insert, when you create an object, everything is okay because you have already passed the precondition. But it seems that you assume that it's a kind of a posteriori consistency check. You have object diagrams, and you want to be sure that they all fit the rules of the class diagram. Why this distinction between, why this selection of a posteriori, and why you don't consider this a priori? Because it would be easier to have object diagrams that by construction are instances of the class.
Let's suppose we have some state diagram. This is a state diagram, state chart. We have class diagram, and it has only one class A. And this state chart diagram is basically representing a behavior of object of class A. Okay. So this is also object diagram, but it is representing the behavior. So we create an object, we create an instance, like if we are talking about some customer website, some website online shopping. So this is me. I take birth in this website now. My object take. Now it has some behavior. Now another object came. It has some behavior. So the birth of this object is checked by this. So if there is restriction, only two instances can be there at one time.
This a priori by checking would mean that when you create the object, you assure that it is
legal to create object here, or it is okay. So in our model we have described only two models can be here at one time. Two objects can be here at one time. So if system try to create third object, so this thing is error actually, because our definition is not allowing us to create. So this is the basically.
Yes, I was thinking in this kind of more functional oriented perspective, where again the consistency is done at the creation time. You create the object, and if you see that the object has is being specified related to different diagrams, you just create it with all the connections that assure that its definition is correct. It also could be done, but in many cases you can do it a priori or a posteriori if you find a scenario where objects are there and you need to know if they are behaving properly. Okay, I also was curious about when you made the consistency of multiple UML diagrams. And at the beginning I thought that these multiple UML diagrams were different UML diagrams. After reading the chapter, I saw that you are merging models that depict the different versions of a UML model. So it's just it's a kind of schema evolution, model evolution. You have different versions and you create a consistent version. That is okay to me. But I was curious about this. My first assumption: if you are, why don't you consider to explore the connection and application of the approach for checking consistency of different diagrams that will connect directly with the application to MDD tools? Because in model-driven development tools, you have these different diagrams that you need to be sure that they are consistent, and this has a clear industrial value. Could you extend what you have done to this contest? My answer, I think that is clearly yes. And why haven't you done it yet?
To me, this work is also valid for your assumption, first assumption, because I have written that we can validate multiple models of same meta model. So same meta. So if they are following one meta model, it doesn't matter whether they are different versions or they are different diagrams. So just one thing we need, that they must follow one meta model. That's it. If they both are class diagrams, we can do this.
We go back to the point of the beginning. This high-level ontology where you have one meta model that is providing the glue for the glue for all the different components of in different diagrams where you can have structure, behavior, interaction, probably. I think that as I told you at the beginning, you must explore this connection, because probably it's a context where the ideas are going to be really applicable. So you will have more detail, but I think with that I'm covering all my essential points. So I'm ready to close my exposition. Thank you.
Okay, so then I think it's time for your statement.
Okay, so I think that evaluating a PhD award is a very hard issue, a very serious issue, of course. We try to apply a kind of scientific approach. There is a problem under investigation. I like to use the words, the methodological perspective of problem under investigation, treatment of a design for solving the problem, and validation and implementation of the detail. I think that in this case, in this PhD, the problem under investigation is very clearly stated. It's a very relevant problem, as I have said before. How to check the consistency of modeling artifacts using UML as a reference modeling language with a degree of automation that should be as high as possible. It's a very clear problem, and it is very well founded, very well explained, very well motivated in the document. Of course, the next aspect to be considered is what others are doing to solve the problem. It must be justified that we need a better solution, we need solutions. I think that in this work, the related work, the state-of-the-art analysis is very sound. I have found all the references that I consider relevant for understanding that the community is trying to solve the problem, but we don't have yet any final solution at all. So we need research and we need solutions. It is a multidisciplinary work. This is important because this adds complexity to what have been done. Model-driven engineering, ontology engineering, web engineering, conceptual modeling, information systems, software engineering in general. So I think that all this analysis that is present in the structure of the work clearly shows that a better approach is required, And the next step, of course, is to provide a solution and to evaluate the solution, the contribution to the problem that is the most hard task for sure. In this case, I think that the PhD is doing a good job at this respect. I think that there is a very precise set of contributions that fit very well the initial research objectives that are presented in the document, what gives a very solid structure to all the work. The contents, if you look at the contents of the work, you see that there is a clear structure where you have first the problem, the related work, the solution, and the application of the solution. I would like to emphasize as the main contribution the idea of proposing a concrete representation of UML class diagrams in O2 and the subsequent validation of UML class diagrams and meta models using the all two reasoners in order to provide this capacity of checking consistency of conceptual models with a high degree of automation. The first contribution is exemplified by validating more than 300 meta models available in an online repository, what provides a proof of validation that is important to comment. This is probably the essential component that for the first time introduced the idea of linking UML models with ontology reasoners in a concrete way and with concrete results. And I think that what is probably very interesting in the work is this first result is just explore till the end. You just go step by step. It's a kind of steps there where you check consistency of class diagram and state charges diagram with the state invariance, showing that the consistency of diagrams that are expressed in different languages makes sense under the approach. You then apply the approach to a different scenario, that is the analysis and consistency of design models that create behavioral REST interfaces for web services. That is again a new step. You go further with that. You reason after that about the conformance of a UML object model against the class model, as we were commenting, always using the corresponding O2 reasoner. You validate multiple UML diagrams with the meta model. I mean, the idea is that you start from a concrete proof of transformation, and you apply the idea more and more. You extend step by step the approach in different scenarios, all of them related to improving the quality of models under a model-driven perspective approach. So I think that the set of contribution is very complete. I think that is fair to conclude that we face a really good PhD work where clearly original, relevant and significant contributions are provided for a really interesting and complicated problem. The structure of the PhD is important to me, it's extremely clear. I have learned a lot reading your work because it's very well reported, very well written, very easy to follow and understand. I think that each one of the previous main contributions is perfectly visualized in the corresponding section, what makes sense and helps to transmit very clearly the central messages. There are a set of publications that also show that you have discussed your work in relevant events. You report in every chapter an article that has been the concrete result of your work. This shows that there is also, as I was saying, there is an international perspective on the results. From the experimental perspective, there is good news to me to see that there's plenty of things to do. I think that I wouldn't consider at all that things are done. You are in the middle of the game. You have to go further, especially with all this set of experimental issues that are clearly opening a lot of opportunity. So, for all this reason, it can be concluded that the work presented by Mr. Ali Hanzala shows a very rigorous research work where a challenging problem has been faced and where a set of innovative, original, relevant and significant contributions are provided, what clearly improve the current solutions to the problem, especially in the widely used UML modeling context. I wouldn't say that the problem is over. There are space for much more things, but it's clearly a step forward. This is why, and more formally, I clearly state that with respect to the thesis and the defense, it is hereby possible for me to recommend to the Department Council that the thesis were accepted for its aim.
I would like to thank for the comments that the opponent has presented. I call upon those present who for their part would like to comment on my thesis to ask Custos for permission to speak.
Okay, so the public defense of the doctoral thesis is here complete.
There will be cake and some drinks at fourth floor. You are all welcome to join after 5-10 minutes.
So,
Thank you.
More relaxed now.
Thank you very much.
I think it will. You did a really good job.
Thanks for being here. Thanks for being Thanks for being Thanks for being Thank you.
So be
Ya, o sea, Io mi dedico a sé, io sono qua.